Hi, my name is Talha Khan, and this is assessment to rostering. This is task 4, the video hurdle. And I'll jump straight into the first constraint of task 1. And this constraint basically calculates the total penalty for not satisfying the request of the workers or the employee rather. So it checks if the request is on and the employee is assigned a shift that, or is not actually not assigned a shift that day, or if the request is off and it's assigned a shift, there is a shift assigned, then I just multiplied that by the request weight. The next constraint here, I've introduced a new variable staff, and this just counts how many staff are assigned. So it just computes how many employees are assigned to each shift of each day. This next shift, oh, sorry, this next constraint, it calculates the total penalty for understaffing and overstaffing. So if there are fewer employees than needed, then I'm applying the short cost. And if there's more required, more staff than needed, then I'm applying the over cost here. And of course, multiplying it with however many are short or over staff. The next constraint here is just to make sure that I am limiting the number of shift of each shift type for each employee. And I'm making sure that they are either less than or equal to the max type shift. So however many they're allowed, the maximum number if they're allowed. Yeah. This next one, I'm making sure that the total assigned work time is within the allowed range of their minimum and maximum time that they can work. So yeah. This next shift is just to, sorry, the next constraint is to make sure that they don't work on multiple weekends, so they work on as many as they're allowed. Yeah, as many, so they're less than or equal to the max weekend allowed for each employee. Right, this next and last shift for task 1, it basically prevents the transition from one shift to the other, and well, it stops whatever is prevented in the shift prohibit set. So, because some shifts are not allowed to follow others directly, so this constraint blocks those combinations, whichever are in the data files. Right. So now moving on to task 2. And in task 2 here, the first constraint here is just making sure that each surgery is scheduled and they are within the valid horizon, planning horizon, right? And also making sure that they're less than or equal to the shift length. Right. The next one is just making sure the operations or the surgeries are within the possible dates mentioned in the data files. And this next one, I'm making sure that the surgeries fit within the shift. So the constraint checks that the surgery starts and ends within the shift duration, basically. That's all it does. Um, this next constraint, it makes sure that the required roles for the surgery are present. So it looks for each surgery and the required role, right? And it looks at only the employees whose roles are declared or they match the required role. And then it just checks if they are assigned to the correct surgery on that particular day. Right. This next constraint, it checks that it makes sure that staffs are not assigned two or more surgeries that happen at the same time. So what's happening here is if an employee has a surgery on a particular day and the next, so that if they have two operations, then what I'm making sure is that they don't overlap, nor are they scheduled. So basically, if an employee is needed for two different surgeries, then they both cannot be on the same day. But if they are on the same day, then they cannot overlap, right? So that's the constraint that this one does. And then I've introduced a new variable here called op theater. And what this constraint basically does is it prevents the theater confliction. So what this constraint makes sure that there's no two surgeries scheduled in the same theater at the same time, right? So it only allows multiple surgeries to happen at the same time, only if they're in different theaters or at different times. Now, this next constraint is not directly mentioned rather in the task or the instructions, but I feel like they are necessary. What this constraint does is it loops over each of the indices, so all the operations, and it decides either the operation must be scheduled on an earlier day, or if they're scheduled on the same day, then one must start before the next, right? That's all this constraint does. Next, I have introduced another variable called the latest surgery end, and all it does is with this constraint here, is it saves the latest surgery whenever the latest surgery is. So it finds the surgery that ends last and it stores it to the end time variable, this latest surgery end, stores it there. And then I've kept everything else the same, other than when I'm minimizing, I've added the latest surgery end. So based on this constraint here, what's going to end up happening is all surgeries will at least try to be scheduled early on during the day and the particular shift that the surgery is assigned. So it'll try to happen early. So it'll try to end it as quickly as possible, which means it will also start as quickly as possible. So, yep, that was the video, and thank you for watching.